Hello, everyone. My name is Arvind. I'm a program manager on the Azure Cosmos DB team. My session had an obscure title, but really I'm here to talk about the newly announced Azure Cosmos DB. So how many of you know what I'm talking about? Have you attended the keynote? Do you know about Azure Cosmos DB? Good. So Azure Cosmos DB is a globally distributed, horizontally scalable, multi-model database. So what does that mean, and why does it matter? Um, Now, if you go trace back to applications, what do applications need and how applications have evolved over the last few years? If you look within Microsoft, what we heard from a number of developers is that now more and more we are building applications for a globally distributed user base. So what does that demand from a database? So you can write an application that is spread across multiple different geographic regions. But what happens with the data? The data often gets left behind. So who would distribute the data, and how do you bring the data to where your users are? So that's where a distributed database comes in. That's where things like global distribution, elasticity, and response time become important. If you can imagine you're building an application that is targeting a user base that's spread across the world, then how does your database manage to present that information without being closer to the user base? So let me play a quick video that shows about Cosmos DB, its evolution, and what it can do for you.
Imagine a horizontally scalable database that puts data everywhere your users are. It seems intuitive, but most databases are still light years away from true turnkey global distribution. Azure Cosmos DB offers the first globally distributed multi-model database service for building planet-scale apps. It's been powering Microsoft's internet-scale services for years, and now it's ready to launch yours. Only Azure Cosmos DB makes global distribution turnkey. You can add Azure locations to your database anywhere across the world at any time with a single click. Azure Cosmos DB will seamlessly replicate your data and make it highly available. Azure Cosmos DB allows you to scale throughput and storage elastically and globally. You only pay for the throughput and storage you need, anywhere in the world at any time. As the first and only schema-agnostic database, Azure Cosmos DB automatically indexes all your data so you can perform blazing fast queries. And since no data is born relational, the multi-model and multi-API capabilities remove the friction, allowing you to build with any data model and API. While most database services force you to choose between strong or eventual consistency, Azure Cosmos DB provides multiple, well-defined, intuitive consistency choices, so you can select just the right one for your app. Take off with confidence, knowing Azure Cosmos DB provides guarantees and comprehensive SLAs other databases would never attempt. High availability, consistency, throughput, and single-digit millisecond latencies at the 99th percentile. Your app deserves a globally distributed database service that's out of this world. Welcome to Azure Cosmos DB.
OK. So let's drill into the things that were mentioned in the video. It touched upon a number of things that are important to building distributed applications. So the gist of it, if we look at the key attributes of Azure Cosmos DB and distributed databases in general, are these attributes, the core of which everything centers around global distribution. So how do you distribute your data and requests across multiple geographic regions? Then you have the issue of how does it scale. So when you're starting, does your database scale in terms of storage? Does it scale in terms of throughput? How turnkey is it? How automatically can it scale storage and throughput? How fast is the database? So like what happens to latency? Can you serve reads and writes within milliseconds? And how do you build correct distributed systems applications? So how do you handle with your data being spread across these multiple copies? And how do you deal with the CAP theorem? How do you deal with consistency and the trade-off with availability using well-defined consistency levels? And the last is SLAs. We build a service. So what SLAs can the service bring for you? So Cosmos DB brings the best attributes in all of these different areas. So when we built Azure Cosmos DB, it was, it was for internal Microsoft needs. We found across the company different products within Windows, within Azure, within Office, all needed a globally distributed database that was elastically scalable, because at any point your application could go viral. It could go reach 1 million users, and then you need to scale your database, so it should be able to seamlessly scale in terms of storage and throughput. It has to be highly responsive. So no matter where your users are, no matter what the scale of the data, it has to be instant, because user expectations have grown tremendously over the last few decades. It always has to be on. So even if the region were to be hit by a meteor, you want your application to continue functioning. So how do you build that always-on application from the ground up without having to inherit a whole bunch of technical debt? And last is no data is born relational. So how do you reduce that relational tax? So you have to set up your relational schema, you have to model, and every time you need to deploy a change to your application, you need to go update the schema and then update your application, which creates a significant overhead when you're developing applications. So how do you reduce that tax of maintaining your schema and maintaining your indexes? That was one of the key goals of Azure Cosmos DB. The flexibility. So if going with modern application development practices like continuous integration with side-by-side versions, experimentation, how can you have a database that supports these different schemas side-by-side, so different versions of your apps can run at the same time? And of course, all of these problems become amplified with global distribution. So if you have multiple copies of your database, how do you even apply a schema migration? You have to do it in multiple steps. It's error-prone. So having a database that's flexible in terms of schema makes it really easy, or much more flexible, to build these, iterate and improve and innovate on your products. And lastly, total cost of ownership always becomes a very key factor when you're designing, when you're choosing a database technology. So you want something that has truly elastic pricing, where you only pay based on what you need, both in terms of storage and throughput. So these are the key attributes you need from a database. And lastly, like when we built Azure Cosmos DB, we wanted to stand behind our tech. So we wanted to offer all of the things that you need, like availability, consistency, throughput, and provide SLAs and be transparent about how the service forms, how the service behaves and holds up its end of the bargain. So the first and the most important part, like when you're working with a distributed database, is global distribution. Now, Azure, like among all the cloud providers, has the biggest footprint. So we are present in 40+ regions, and Azure Cosmos DB, as a foundational component of Azure, is available in all regions and will be available in all regions on day one. In addition to this, when you set up your regional number of regions associated with your account, it is turnkey. You essentially point to a map and select the regions that you want your data in, and it would automatically get replicated to all of these regions within minutes. So you can start small. When your application starts small, you would set up a single region. And when you need to add more geographies, it's a matter of just provisioning, running a script, or pointing to a portal, and your data would get replicated by default. And you can add and remove regions. And in case you want a region where to go down, you can set failover policies. And the failover could be manual or automatic. So if you wanted to test the resiliency of your application to a regional disaster, you could do that with our manual failover APIs, and we guarantee no data loss during that failover. And lastly, we have multi-homing APIs. These are built into our SDKs and APIs. So if you have a globally distributed application, for example, you're spread across Europe and US, your database will be distributed across these regions, and your application that's running in the US region would be home to talk to the copy of the data in the US. And the application that's running on the Europe side would be talking to the homed copy of your data in Europe. So both your applications running in two ends of the globe have low single-digit millisecond latency. But at the same time, you get guarantees that the data is persisted, and you have a reasonable consistency model. You also have elastic scale. Now you can think of this as a second dimension. You can scale out in terms of regions, and you can also scale out within a specific region in terms of both storage and throughput. And what is unique about Cosmos DB is that you can independently scale storage and throughput. So if you have data workloads that have large amounts of data, but then you have infrequent access patterns, you could do that, and you only pay based on what you need. Or if you need a high volume throughput, you need to scale to millions of requests per second, you can also do that with Cosmos DB. Let me show you how easy it is to scale in Cosmos DB. And this is our portal. And of course, we have programmatic APIs in various platforms. So when I provision an account, all I need to do is I need to choose my throughput, which is the number of requests per second that you need to provision. So let's say I need 100 requests per second. All I need to do is configure a single number on my account, and Cosmos DB will guarantee that throughput. So you don't have to think about memory, you don't have to think about IOPS, you don't have to think about VM sizes. All of that machine management, the scale out, the seamless distribution of your data and automatic partitioning is handled by a single number. And this is your unit of work in Cosmos DB. And at the same time, if you need to change throughput, it's just a matter, within seconds, you can go change your throughput, and you can scale up or scale down, and Cosmos DB handles that automatic distribution of data, automatic distribution of the throughput budgets behind the scenes. And all you need to provide with, in addition to the throughput, you also provide us a partition key, so you tell us how your data is distributed. So this was one of our customers. Like, for example, this was Jet.com during their Black Friday weekend. As you can imagine, they were running at around 1 million requests per second, but they knew things would spike rapidly for Black Friday. So they were able to scale up their throughput to 10 million requests per second. And of course, they scaled back and forth based on their testing and usage patterns. But you can see the power of such an elastic system, that you could just scale up to 10 million requests per second when you need to, and then scale it back down when you don't, so you're not stuck with the bill of a big VM or a big cluster of VMs. You're essentially just completely elastic. The next part is of a distributed database like Cosmos DB is guaranteed low latency. So what this means is, regardless of the size, regardless of the number of different requests that are going on at the same time, regardless of what else is going on in a cluster, we guarantee the 99th percentile of read and write latency. Now, this is important, and you might see the fine print in other database vendors talk about latency in general, but no one talks about the high-end latency. And this is extremely important, because if you're building mission-critical systems, a slow database is as good as a database or as bad a database as something that's not available or completely down. So latency is extremely important when you're building your event processing systems, you're building your inventory processing systems, you're building homing services. Like, several mission-critical applications in Microsoft run on Cosmos DB, and they rely on this low single-digit millisecond latency at the high end. And that is made possible because of our write-optimized storage engine, as well as our scale-out architecture that is effectively, no matter how much data you have, we are effectively able to scale out in time to guarantee these latencies. And in practice, of course, like, the median latencies are much, much better. And lastly, we talked about global distribution. When we talk about global distribution, you might have heard of the CAP theorem. And the CAP theorem is one of those truths that there is no escaping it. It's a fact of life. So what it says is, if you have data it's in the US here and Europe over there, if you want strong consistency, there is no light takes about 100 milliseconds to travel that distance. So your database cannot be faster than that 100 milliseconds. So the only true answer to solving it is by having the data close to where those users are. And now what this means is, you have to trade something off. This means that the data here could be stale. So what do you, like, like existing NoSQL databases, for example, give you two choices to deal with this. They say either your data is consistent, you get strong consistency, but it's slow, or you get eventual consistency, which is fast, but all bets are off. I mean, your data could be there, it could not be there. What we do is we let you write correct distributed systems applications. And that's possible because we give you these intermediate consistency levels, like session consistency, like bounded staleness consistency, and consistent prefix consistency. Those are very useful for real-world applications. We have a ton of details in our documentation, so you can see and pick what fits your application. Most of our customers tend to pick session consistency because it gives you strong consistency within the scope of a session. But this is a very exciting space, and it gives you that trade-off where you get the best of both worlds. And lastly, comprehensive SLAs. SLAs like these have not been done before. We offer SLAs. Normally, databases provide availability SLAs. We have 4 nines SLAs, and this is possible because all your data, we keep 4 copies. Every write, for example, is quorum committed, durably committed on disk, durably written to disk, automatically indexed before a client gets ACK. And because of this reason, we are able to provide the high availability. In addition to that, we also guarantee throughput. So when you say, I want 1 million requests per second, we guarantee that you have that 1 million requests per second. And we guarantee the latency. So the high-end latency at the 99th percentile is guaranteed to be single-digit. And consistency. So we will always give you your requested consistency level, and that's backed by SLAs. And all of these metrics are transparently available to you as an API. So when we violate one of these consistency levels, we would let you know via the graph, and you can keep us accountable. So this is what I mean by Cosmos DB stands behind its own tech. And lastly, Cosmos DB is API agnostic. So you can bring your applications, your data as it is. So we like to say no data is born relational. So relational modeling is almost an afterthought. You try to bring your data in the real world and apply a structure to it. With Cosmos DB, you can bring the data as it is. So if you look at your APIs, now they are naturally modeled in a document structure, or your APIs might be key value like, or your graph. Graph is very powerful, models the real world effectively. So all these API models seamlessly work in Cosmos DB, and you can use the one that you like. Like for key value store, we bring the popular Azure storage API. Using the service we used to previously call DocumentDB, we supported SQL querying over structural schema-less data. We supported JavaScript-based access. You can use those APIs. We support the popular MongoDB API. So if you have MongoDB applications and you need global scale, global distribution, you can bring those applications, just switch out a connection string, provision your throughput, and go. And lastly, the new kid on the block is Gremlin APIs. So if you have graph workloads, like you have logistic applications, you want to find the shortest path for the truck. You want to see how do you route a truck? How do you build a recommendation system? What do people who like this product, what do they also like? If you want to do those kinds of queries, graphs are extremely efficient. So you can use those APIs to build those applications. And as of right now, you can even, to a limited extent, mix and match these APIs. So you can take data that is document-like and add graph capabilities. And our vision is to support these seamlessly across over the same stack. And we are expanding what we have. We're going to support a number of other popular OSS APIs and also bring new data models as they become more popular. So a quick overview for do many of you use Azure Table Storage today? Yes. So good news is we have a premium experience for table storage. So now you have global distribution, secondary indexes, you have millisecond guaranteed, single-digit millisecond latency, and most of the top user voice asks that we see on the customer voice site. So you can have a premium, you can have the standard API running on table storage, or you could have the premium API, which works with the exact SDKs with the same APIs. And of course, we will support the same feature stack over both standard and premium tables. So you'll see the same capabilities come in standard tables as well. The Gremlin API, we talked about Gremlin. So you can use open source Gremlin drivers. You can use Gremlin tools and consoles to have globally distributed. I mean, this is first of its kind, a globally distributed, elastically scalable graph database that's optimized for these kinds of problems. And lastly, this is, we didn't talk about this a whole lot, but Azure Cosmos DB is always encrypted, automatically encrypted at rest and in motion. It has a highly scalable row-level authorization model, and it has comprehensive compliance in Azure. So it is built for these kinds of applications that have these requirements as well. So in summary, what you get out of Cosmos DB is global distribution, limitless scale, well-defined consistency levels so you can write correct distributed systems applications, guaranteed single millisecond latency, and API of your choice. So we have a ton of information here. We have a booth over there. We're happy to discuss more details, walk you through code. Thank you for attending.